All right, 7.3 applications problems. So remember your formulas. Here we have, growth by the plus, decay by the negative, and here's compound interest. So when it gets more complicated, that's compound. So it says in 1995 there were 85 rabbits. Population increased 12%. How many were in 2005? Well, first off, you need to look at that right there. And notice that's 2005 minus 1995 is 10 years. So we need that for the formula. So the future amount is equal to our starting amount, 85. That's the A sub O. And then 1 plus, remember this is 0.12, change it to a decimal always, to the power of 10 years. And that's going to be 263 rabbits. Now, I'm not going to do all these in the calculator, but just want to talk about a couple things real quick. So first off, when you're doing a problem like this, make sure that you're doing it in the right order or use the right notation. So 85 parentheses 1 plus 0.12, close that, then to the 10th power. Now notice, most people would want to say that's 264 rabbits because you're going to round up, because 0.99 says round up. But in real life problems like this, we don't have that 264th rabbit. It's really close, okay? Maybe he's just missing a little toe, but we don't have a full 264 rabbits, so we actually round down. So in real world situations, the rules of rounding don't apply. How many rabbits do we actually have? 263. Okay, number 2. Total number of student failures is decreasing 3% each semester. So we're going to use the minus 1. All right. If there were 324 originally, after 5 years, where will it be? So again, future value is based on the starting number, 324. We're using the decreasing formula. 3% is 0.03 and 5 years. And when we do that, we get 278 students. Number 3. Again, we're going to have to do a subtraction problem. So that's going to be 25 years. All right. Here's our number. Remember, we're going to move it twice. So 0.056. Here's our starting number, 25 million. Now, we're not going to put million. We're just going to put 25 and say our answer in terms of millions. We don't need to have this huge number. So since it's increasing, that means we're using our plus formula, 0.056, 25 years. Now we get 97, and all we do is say 97 million households. So since this is 25 million, this is 97 million. Number 4, insulin used to regulate sugar in the bloodstream breaks down. Okay, that means decreasing, decay, about 5%, 0.05, each minute after injection. So we have to pay attention to that because it tells us later 90 minutes. So one dose is 10 units. That's our starting point. So we're starting with 10 units. It is decreasing 5% over 90 minutes. And that gives us 0.098. That's how much will be left. Number 5, student has a baseball card worth this much. That's our starting amount. Mess that up there, 26.35. It wants to appreciate, so that's plus 2.5, 0.025, and it wants to know what it will be worth in 10 years. So that is $33.73. Nick bought a four-wheeler with his money, own money. Here's the equation right here. Whoops. It says how much did he pay for the four-wheeler? Okay, that's the initial amount. What's the annual percentage rate, okay, of depreciation? That's not it, okay? Remember, this formula would have been 1 minus something to give us that 0.78. So 1 minus 0.78 is 0.22. So that's 22% depreciation. So this would have been written 1 minus 0.22 like so. So we worked backwards to find out the 0.22. All right. Autumn invested her money from working at Target. She didn't touch her money for 10 years. That's the 10 right here. Here's the equation. How much does she have in her account after 10 years? That's the future value right here. So that's $19.20 and 13 cents. That's supposed to be a 13, not a capital B. How much money did she make after 10 years? Well, what we have to do is she put $1,500 in. So we have to do 1920 minus 1,500, which would be $420.13. Annual percentage rate, right here. Okay, so remember, it's 1 plus something, so that's 0.025, which is 2.5%. Number 8, more identification. What's the initial investment? That's right here, $2,200. The interest rate is right here, 3.5%. The number of compounding periods is this number that repeats right here and here. So that's 4. And the time is the odd man out. So the two matching numbers are the compounding periods. The other number is the time of investment. Now we're going to do a few of those. So Sam invested $2,500. That's the starting amount. 1 plus every time. It says the annual interest rate is 6%. That goes up here. Compounded daily. Okay. Now there's two numbers you use here, 365 or 360. Banks use 365. As long as you show your work, either one, I'll accept either one. 8 years. So again, this number repeats. That's the compounding, and then times 8. Okay. So what do we get here? We get $945. That's not a 4. 45 and 33 cents. Oh, my bad. That's the wrong one. Getting ahead of myself. It is $4,040. That didn't make sense. You lost money. And 2 cents. The next one. This will look familiar. Okay. You put $700 in. It says this is always 1 plus. 4.3% interest. That's 0.043. Compounded monthly. There's 12 months in a year. So that goes there and there. And after 7 years, we do times 7. Okay. This one is $945.33. Number 11. The initial amount was $21,000. Always 1 plus. Interest rate is 0.132. It says compounded semi-annually. That's twice. That number goes there and there. And for 12 years. 2 times 12, that's 24 up there. And we end up with a grand total of $97,362.60. Right? Lori invested $5,000 in her retirement account in 1989. We're going to have to subtract those two to get 26 years. 1 plus, all these are plus. 6.05, that's 0.0605. Compounded weekly, there's 52 weeks in a year. That number goes there and there. And then that's times 26 that we calculated earlier. Now when we do that, we get $24,083.41. Last but not least, they're investing $1,800. 1 plus every time. Interest rate is 6%, that's 0.06. Compounded weekly, again, there's 52 weeks in a year. That number goes there and there. And then it says 10 years. So that gives us a grand total of $3,278.67, and that's